Hai kelas, Assalamualaikum. Sorry, saya ada tertinggal satu slide untuk awak. Okay, topik friction actually. Topik friction ni masuk dalam test 2. So, kita go through sikit. Kat sini kita nak perkenalkan awak apa itu friction and apa itu karakteristik of direct friction and also how to do problem solving for direct friction. Okay. Alright, friction, the characteristic of direct friction and also the problem solving direct friction. Dalam topik ni kita tengok application, characteristic of direct friction and problem involving direct friction. The objective for today, you all be able to understand the characteristic of direct friction. You know how to draw FBD including friction and solve problems involving friction. Okay. Okay, kita cubalah tengok ni reading quiz. A friction force always acts. Friction force selalunya dia act apa? Agak-agak normal ke, parallel ke, 45 degree ke, at the angle of static friction. Okay, so the answer is parallel. Okay, tapi in different direction. Alright. Okay, next. Right. If a block is stationary, okay, then the friction force acting on it is, jawapan dia nanti kita tengok apa answer dia. Right, application ni kita nampak biasalah kalau seorang naik basikal kan, dia orang design brake system bicycle ni sama ada car, okay, bicycle or other vehicle by applying the frictional force. Okay, kita kena faham lah frictional force ni kat mana application dia. Alright, okay. Other than that, for an applied force on the brake pads, how can we determine the magnitude and direction of the resulting friction force? Alright. The characteristic of direct friction, as we all know, friction it is defined as a force of resistance acting by the body which prevents or retards slipping of the body relative to a second body. Right? Yang mana force yang resistant acting on the body in which it prevents or retards slipping of the body relative to second body. Mana contoh blok ni dengan permukaan ni. Okay? Okay, experiment show the frictional force act tangent, okay, which is a parallel to the contacting surface in direction opposing the relative motion or tendency for motion. Okay, so jawapan tadi yang pertama adalah parallel. Okay. Okay. For the body shown in this figure, right, to be in equilibrium, alright, the following must be true. Okay, di mana kalau nak jadikan di equilibrium, F is equal to P, right? Okay, frictional force equal to P, normal force equal to weak. Okay, weak X equal to PH, right? PH maksudnya apply force P dengan distance H dan weak dengan distance X. Right? Okay. To study the characteristic of the friction force, let us assume that tipping does not occur. Okay. Kita nak cuba tengok characteristic of friction force. Kita assume that tipping does not occur, di mana H is small ataupun A is large. Okay, H ni small ataupun A ni large. Then we gradually increase the magnitude of the force P. Typically, experiments show that the friction force F varies with P, as shown in right. This one. Okay. Eksperimen tunjuk frictional force F ni vary dengan P. Okay, ni adalah figure untuk friction punya graph di mana menunjukkan F equal to P di sini. Alright. No motion will occur until static friction stop. Which is bila motion ni berlaku, kinetic friction baru bermula di sini. So maknanya no motion ni adalah mana dalam proses you punya block tu nak start to sleep. Tapi dia belum sleep lagi. So maknanya bila dekat sini dia adalah mu ni reading dia. Okay. Bila coefficient of friction ni increase sampai value dia 1, alright, then baru dia start to move ataupun start to have a motion. Then we call here is kinetic friction, which is mu k. Mu s selalunya lebih kecil dari mu k. Alright? Okay. The maximum friction force is attained just before the block begins to move. Okay, maximum friction force ni is attained just before the block begin to move. Maknanya kat sini maximum friction force. Okay, is a situation that is called impending motion. Alright, impending motion. Okay, the maximum friction force yang attained just before the block begin to move. This situation we call impending motion. Okay, the value of the force is found using F S equal to mu S N, di mana Fs is static friction, mu S is coefficient of static friction, N is normal force. Okay. Okay, this mu S depends on the material in contact. Okay. Once the block begin to move, okay, the frictional force, okay, typically drops and is given by equation F K equal to mu K N, di mana Fk is kinetic friction, mu K is coefficient of kinetic friction, and is normal force. And dia cakap sini, the value of UK is less than mu S. Sorry, yang ni silap. Okay, the value of UK is less than mu S. Right? Betul lah. Alright. A block with weight W is placed an inclined plane. Okay, di mana the block ni berada di inclined plane. The plane is slowly tilt until the block just begin to sleep. Okay, the plane is slowly tilt until the block just begin to sleep. Right? The inclination is theta s. Noted. Analysis of the block just before it begins to move gives using static friction equal to coefficient of friction normal force. Okay, Fs equal to mu S N. Alright, so how we solve this problem? Alright, okay, in condition here we know that the weight is to the follow gravity punya ni kan. Alright, so W is here. Alright, we know that this is theta S. Alright, friction force selalunya dia mesti in contact dengan surface. Alright, so kita punya Fs equal to mu Sn, dan kita punya normal force mesti perpendicular dengan body kita. Alright, so kat sini sekarang kita punya Fy adalah apa? So Fy kita dia letak dimension ke sini, dia letak annotation ni ke anak panah ke kiri dan ke atas ni positif. So Fy awak ada N positif kan, tolak dengan W cos theta S equal to 0, di mana summation of Fx equal to 0, dia buat annotation ke kanan atas ni positif. So you ada Fs kan, which is mu S N. Okay, tolakkan dengan alright, yang tadi ni ke sini kan. So W sin theta S, alright, equal to 0. Okay, using these two equations, we get mu s equal to W sin theta s divided by W cos theta s equal to tan tangent theta s. This simple experiment allows us to find the mu s between two materials in contact. Alright. The problem involving dry friction. Okay, step for solving equation problems involving dry friction. First, draw the necessary free body diagram. Okay, macam biasalah. Apa yang kena buat? Selalu kita akan draw F, B, D. Make sure that you know the friction force in the correct direction. Alright? It always oppose the motion or impending motion. Okay, di mana awak tahu dia nak jatuh ke bawah and automatic dia akan bertentangan. Force dia akan move bertentangan. Dia parallel tapi dia bertentangan. Oppose the motion. Okay? Okay, number 2, determine the number of unknowns. Okay, once you dah draw FPD, okay, you determine pula number of unknown awak. Okay, do not assume F equal to mu Sn unless the impending motion given is condition is given. Alright. Okay, third, apply equation of equilibrium and appropriate frictional equation to solve the unknowns. Okay, macam biasalah. Macam sebelum ni punya problem solving punya method. Okay, example 1 given. A uniform ladder, weight dia 20 Newton. Okay, vertical wall is smooth. Kat sini tak ada friction. The floor is rough. Okay, dia ada mu s equal to 0.8. Okay, soalan minta find the minimum force P needed to move sama ada tip or slide the ladder. Okay. Okay, plan dia kena draw FPD. And then you determine the unknowns. And then make any necessary friction assumption. Third, fourth, baru apply equation of equilibrium. Alright, to solve the unknown. And then check the assumption if required. Okay, the FPD of the ladder. So, dia tadi dekat point B tak ada. Right, dekat point B dia ada friction. So, okay, dekat B tak ada friction. So, dia hanya ada normal force pada B. Right, normal force mesti bertentangan. Okay, and then dia ada weight tadi kan 20 Newton. Dia ada apply force. And then for dekat point A ada normal force A, alright, and ada friction A, di mana frictional force ni lah yang gambar ada di sini. Sebab ada mu S tadi kan, given mu S, alright, 0.8. Okay, kita tengok. There are 4 unknowns. Okay, you ada NA, you ada FA, right? You ada NB dan you ada B. Okay, let us assume that the ladder will tip first, and then normal force B is equal to 0. Alright, dia akan tip dulu. Okay. So, bila tangga tu naik, so dia punya normal force B ni akan jadi 0. Okay, so apa kita kena buat? Biasalah, kita buat equation of equilibrium kita, summation of Fy equal to 0, di mana annotation ke atas positif. Alright, so kalau ke atas positif kita ada Na, right, minus dengan 20. Kita dapat equal to 0, so kita dapat Na equal to 20. Alright, and then kita nak dapatkan, sekarang nak cari nilai P. Kita apply moment dekat E. Bila apply moment dekat E, alright, so kita dapat nilai P, di mana apply moment dekat A, you ada 20, kita buat assumption clockwise positif. So, 20 rotate dengan distance 3, positif, alright. P akan rotate dengan distance 4, counter, negatif. So, kat sini you akan dapat P equal to 15 Newton. Alright, summation of Fx equal to 0. Sekarang kita nak dapatkan Fa pula Na dah dapat, P dah dapat, Fa. So, Fa kita, summation of Fx equal to 0. Kita ada, apa tadi? P 15 kan? positif 15 tolak dengan FA. FA negatif sebab dia ke kiri. So kita dapat FA is equal to 15 Newton. Alright. So now kita check assumption kita. Di mana kalau nak dapatkan frictional force maximum, kita darabkan US dengan NA, di mana 0.8 darab dengan 20 Newton tadi, itu normal force pada A is equal to 16 Newton. Okay, is FA equal to 15 Newton, dia kurang daripada F maximum which is 16 Newton. Yes, so our assumption kita adalah correct, di mana tangga tu tipping. Okay, dia naik, dia tertolak lah. Okay, di mana bila FA yang kita dapat tadi tu dekat sini 15. Okay, kita belum kira yang frictional force di mana F equal to mu S N tadi kan. So sekarang ni bila kita kira F frictional force di maximum, kita dapat 0.8 kali 20 tadi equal to 16 Newton. So bila kita comparekan dengan 15 ni, dia adalah lebih rendah. Jadinya betul lah assumption kita yang tipping tu, yang tangga ladder tu tipping. Okay, kita tengok konsep quiz. Okay, you have a 100 Newton box, right, with wide base, is pulled by a force P, which is A, B, and C. And the mu S is 0.4. Which force orientation requires the least force to begin sliding? Yang mana akan memberi akan paling mudahkanlah force to begin sliding. Adakah PA, PB ataupun PC? Okay, force. Okay, the answer. Okay, apa jawapannya? Which force orientation requires at the least force to begin sliding? Okay, dia akan apply force pada point A. That one requires the least force to begin sliding. Alright? Okay. Sebab dia mesti perpendicular. Okay. You punya apply force dengan friction force tu. Sorry, parallel pula. Parallel. Okay. So question number 2. Okay. A ladder is position as shown. Okay. Ladder 1 ni A, B ni. Okay. Please indicate the direction of the friction force on the ladder at P. Okay. So mana friction force on the ladder pada B ni? Okay. Tak ada kat mana? So, bila dia tend to slide ke bawah, so dia akan right. Friction force akan parallel dan opposite you punya apply force. Okay, di mana tangga ni akan slide ke bawah. Betul tak? So, dia punya friction force akan ke atas. So, the answer is C. Right. In class tutorial, cuba kita tengok ya. Yang ini, given drum weight. Okay, drum weight ni 100 Newton. Okay. Mu S 0.5. Right. A awak 3 meter. B awak 4 meter. Tangan tolak apply force ni pada tangan ni. Dan dia ada trigo 3, 4, 5. Okay. Find the smallest magnitude of P that will cause impending motion. Okay, bila dah mention impending motion, baru you boleh guna force equal to mu S N ni. Kalau tak mention, you tak boleh gunalah. Saya kata. Okay, dia suruh cari smallest magnitude of P that will cause impending motion. Okay, sama ada tipping or slipping. Okay, sama ada terangkat ataupun dia slide. Alright, so perkara pertama you kena buat, you kena draw FBD of the drum. Okay, dah draw FBD, you kena determine unknown. Lepas tu make assumption lah jika diperlukan. Lepas tu apply equation of equilibrium. Okay, then check assumption if required. Okay, kita draw FBD kita. Di mana kita ada apply force pada tong drum. Okay, ada trigo sini 3, 4, 5. Distance awak tengah-tengah ni. Okay, ni X 3 mm dan 2 1.5. Right? You ada weight 100 Newton. Okay? Dekat point O ni center dia. So normal force dia akan act pada distance x kat sini. Alright. Okay, ini yang dekat notes awal-awal tadi. So ini memang kita implement jika dia ada mention impending motion tadi. Right, you tahu bila kita tolak, okay, dia akan tend to slip, frictional force akan move opposed to the direction, right? So F is move to the left, which is frictional force. Alright, so there are 4 unknowns yang ada. Kita ada P, kita tahu berapa nilai P. Kita ada normal force kat sini, kita ada F, kita ada F is frictional force, kita ada X. Right, so ada 4 unknown. First kita assume the drum slips. Bila the drum slip, so frictional force awak F equal to mu S and equal to 0.5. Okay, then the frictional equation kita adalah F equal to mu Sn, di mana mu tadi 0.5, N is normal force. Okay. So, F kita sini 0.5 N. Okay, bila kita apply equation of equilibrium, kita ada summation of Fx equal to 0. Okay, di mana annotation kanan positif. Okay, so kita ada 4/5 P. Kita minuskan dengan 0.5 N. Okay, equal to 0. Okay, so kat sini kita ada 2 unknown. Okay, then sama juga kita ada force ke atas positif, summation of Fy equal to 0. Ke atas kita ada N. Alright, kita tolak dengan P 3/5 ke bawah, kita tolak dengan 100. So kat sini kita ada 2 unknown juga. Okay, these two equation akan bagi nilai P equal to 100 Newton dan juga N 160 Newton. Okay, kita buat simultaneous equation lah kat atas tadi ni. Alright, okay, and then kita apply moment pada point O. Bila apply moment pada point O, kita akan dapat nilai X kat sini. Okay, bila moment pada point O, kita ada 3/5 100 kali 1.5. Okay, dapat nilai X ni, kita check sama ada X ni yang kita dapat 1.445 ni kurang atau lebih daripada 1.5. Kalau dia kurang, dia okey. Kalau dia lebih, maknanya dia tak logik lah. So, drum, betul lah assumption kita yang drum ni slips as assumed at P equal to 100 Newton. Okay. Kalau dia X tu lebih dari 1.5, dia tak slip. Alright? Dia tip mungkin. Okay. So, kita ada attention quiz kat sini. A 10 Newton block is in equilibrium. What is the magnitude of friction force between this block and the surface? Okay, what is the magnitude of friction force between this block and the surface? So, friction force dia move to the left. Okay, 2 times 0.3 is berapa? The ladder B is positioned as shown. Okay, what is the direction of the friction force on the ladder at B? So, ladder at B ni dia akan turun ke bawah kan? So, nanti dia punya friction dia ke atas, betul tak? Dia panggil A. Okay. Alright, so your homework tutorial cuba try buat. Okay, untuk test awak dia combine friction part dengan dynamic part. Alright, so friction dia akan ada satu box, ada apply force tapi pada tempat yang rata saja. Alright, okay. Ada apply force P, dia beri box, and then adalah soalan dia yang berkenaan dynamic. Alright, so jangan terkejut pula bila dapat soalan friction, nanti saya dipersalahkan pula. Okay, cubalah buat question 1, question 2 and question 3. Thank you so much. Sorry student, suara-suara anak saya masuk dalam slide kita hari ni. Thank you, sorry. Assalamualaikum.